Hey, what's up, everyone? Good morning, good afternoon, good evening, whatever time of day you are deciding to watch these videos. So, hopefully, at this point, you have gone through all the course introduction materials. I know there was a lot of videos, so I'm going to try to keep this next lecture material kind of short, or at least a little bit shorter than the first one. So, apologies that was long, but there was a lot that we had to cover, right? Canvas, Connect, me, the course. Whew, lots of things. So that's kind of what we had going on there. So what these set of videos are going to cover are basically what we would expect to start covering in our second lecture. So what we're going to be doing is starting way back at the beginning of time. So our oceans came from somewhere. So we are going to consider how the heck they got to be that way. How did they form? Where did all of this water come from? And stuff like that. So that's what we're gonna discuss today. So this will start with our chapter 1 material. I do have you for the SmartBook reading assignments. You do start with a few concepts in the prologue, but then we're gonna, of course, just dive right on into the to our chapter 1. So here we are. So usually if we were meeting in person, I would have here a what I call a picture of the day to kind of get us into the groove, to showcase something generally about the oceans. Usually it's a picture either that I found on Reddit or that I found maybe a satellite image going around with the oceans. So that's usually where we begin. And then I will also generally begin with an agenda slide, kind of like from before. So what we're going to do today is origins of the universe and some early Earth stuff. So I will also tend to have reminders here on assignments or anything coming up that is due. So always be sure to check these as well. So I know you already kind of have a lot going on this week for this class, so you maybe don't have to start chipping away at the SmartBook reading assignments if you don't want to. However, I would recommend it if you have the time, the bandwidth, at least kind of start working through kind of chipping away at the concepts that I want you to cover. And don't forget, really all of the assignments that you have for this week, but of course the discussion board reminder and all of the first week's to-dos. On top of course, the small little assignments that you'll have regarding these videos that are due before we come back together again. Okay, so here's the Earth round. This little screen grab here is from an old school, actually E-Bombs World video called End of the World. If you're not familiar with it, I highly recommend. It's something that I quote at least once a week, if not more. It's very quotable. It's very hilarious. It's showing my age here. I'm only 33, but it's kind of a thing. So kind of really starting back at the beginning. Okay, so but what you'll also see down here at the bottom, if we were in person and in a classroom that actually, no, we wouldn't, because I no longer have access to Disney Plus. If you're like me and you are using someone else's Disney Plus, and you no longer have access to it because, they only allow you to sign in one time, whatever. Anyway, there's this really cool show on Disney Plus called One Strange Rock. It is narrated or hosted, by Will Smith. And what they do is they interview a bunch of different astronauts that basically their worldview has changed from spending time in space in the International Space Station. And so you get to hear a bit about their journeys as astronauts. In this particular episode 2, they nicely kind of go into the origin of Earth a little bit, and they have really cool graphics on kind of like how they imagine Earth had formed. I'm going to talk about it here, but honestly, me talking about it only goes so far. You know what I mean? Like, I can only explain with my hands and with slides so much. So if you have Disney Plus, or if you know someone who has Disney Plus, be like, hey, watch party, let's go watch this silly show that my teacher told me about. Just a suggestion, but you don't have to. But it nicely illustrates these concepts. So First thing we got to consider is that the geological time scale is extraordinarily huge, right? So we think about the origin of our universe. We believe at this time that our universe formed about 3.7 billion years ago. So GA here stands for billions of years ago. I don't know why GA is billions of years. I don't make the rules, my friends. I just tell you about them. So I don't know why that's a thing, but it is. So just know in these slides where it has kind of like this overall time scale, time period, GA stands for billions of years. So 3.7 billion years ago, Big Bang. And then our solar system that we know and love and live in today did not form for another, freaking 7.23 billion years? Like, it took a long time for Big Bang to happen for a universe to form. And you will also hear me mention in these couple of videos I really try to be mindful about saying, as we know so far. And that's because there's a lot of work always constantly going on to better understand where we came from, where our origins are. You know, everyone loves a good origin story, but like there's continuous work going into how we got to be where we are today. So what I am sharing with us in our lectures is what we know now and what are like the current most accepted theories and views within the science community. So just know that I'm going to try to be very mindful about saying as we know so far. I like to listen to podcasts, and it's always fascinating things that that new things are coming up. Anywho'sly do. So 5 billion years ago, solar system formed, but it took 600 million years, or 400 million years, for our Earth to form from that. Like, it took so long. It's crazy how long that takes. And to, if you write out the numerical value of 5 billion instead of just this GA sort of situation, it will maybe come into more context of like how massive that number is, right? So it's kind of just really, really wild to think about. And we'll get further into these other ideas of our other formations later on. But we're going to stick with this idea of Earth forming here for just a few. So also with our own solar system. So our inner planets consist of our small, dense, and rocky planets. These are our friends Mercury, Venus, Earth, of course, and Mars. And so these are beautiful rocky planets. They're very, very dense. Dense meaning they're very compact. They kind of maybe look the same, like Venus and Earth look very similar in size, right? Though Venus is closer to the sun. Venus is also enormously warmer than we are, right? And do you know why that is? Because she's in the runaway greenhouse effect. So way a lot of CO2 in Venus' atmosphere means that heat is continuously being trapped on its surface, and so it's extraordinarily hot. Hopefully that doesn't happen with our planet, and if it does, it will be a long time from after you are no longer in this current state of brain. Whereas Mars is different in that there's not an atmosphere, a very small atmosphere, not very much to it. So we out here trying to terraform Mars instead of fixing what's happening here on Earth. It's fine. But so there's there's differences there, right? In between how close we are to the sun, the composition of our atmospheres. But other than that, we share lots of commonalities. And then we have an asteroid belt, which of course ain't pictured on here. But then we also have our outer planets, which are much larger. They're gassy. They're way less dense. And these can contain rocky cores with gassy outer layers, right? And I know who's not on here. It's Pluto. And listen, Pluto, you're still a planet to me. All right. So I'm going to go ahead and pause the video from here, or have a little stopping point, make this one a little bit shorter of a video. And when we come back, we'll talk about the differences between our former Earth, our early Earth, and today. So with that said, I would like for you to think about, before you move on to the next video, think about what Earth might have looked like before she came to be what she is now. So think about that, and then move on to the next video. Thanks for watching this one.